Okay, CE495. Today I'm recording for ETABS 101 video. Just try to show you how you get started. Okay, so when you open the ETABS, you'll see that images, right? And ETABS academic license, not for commercial use. Yeah, I'm just starting from the scratch. I want you to follow along at least to get to the homework 1 level. So we try to create the geometry first. In order to do that, first of all, you need to go File and open New Model. Right? You see the model initiation, the pop-up. Yeah, this is something that a template. If you want to use the template or setting up the unit with some design base, you could just play around, but I'll just use the default user saved user default setting, and you'll see that new model quick template is a pop-up. Since we are developing 10-story building, right, each floor is 10 feet, I'll just use typical story height 10 feet, 10 story. And the spacing of X, yeah, we are using 10 feet, right? 10 feet wide, X, Y. It doesn't matter Y directions. I'm going to use the X direction. So maybe number of grid line, I'm going to use 5. So I'm going to set up the grid. First, the view is plan view, and you see that 3D view, you can turn on and off, so you can close it. I'm going to just use a plan view, but if you want to add here, you could add a new window view, right? So this is 3D view, so it's up to you. Second, because of this is a vertical, the wall, we are creating on XZ plane, right? First of all, when you look at the plan, you see that XY is on the plan, vertical is in the Z direction. So you see that XY is a left-hand rule. This typically we using Cartesian coordinate system, X, Y, Z. So ETABS always vertical is Z. So you just want to pay attention, X, Y, Z. Now I'm gonna just put this XZ plane, which is on the grid line 1, go to elevation, set the elevation view, and I will pick up the elevation 1. So you see this is grid that we just set it up. So also you can modify later. So if once you use a template, but you may have to adjust it each floor. So go to edit, go to edit stories and grid system, right? You see that all the story data. If you open it, you see that story 1 to the base is total 100 tall. Let's see, yeah, 10 story tall. It's a 100 feet tall, right? You can adjust the floor height if you want, but since we are building the homework 1, I'm gonna keep it. You can adjust it later for your specific region. And also grid system, when you open it, you see that X coordinate, ordinate, right? I create the grid spacing 10 feet, but I include 5 grid. So it set it up to X grid. Y grid, I keep it as a 24 feet spacing and keep the grid 4 grid in Y direction. So it's actually based upon template, it set it up the grid. So now there are many ways to do this. First things, so I'm gonna take a look and show you. Here is the define menu. You see the material property, section property, and other stuff. We're gonna start looking at the material, right? So our concrete wall, I think we use a 4,000 psi concrete. Here 4,000 concrete, 4,000 psi concrete. You'll see that all the properties, especially weight per unit volume, 150 pound per cubic foot, right? This is a concrete weight divided by gravity accelerations. We'll calculate the mass. So 150 divided by 32.2 the feet per second square, right? So you get this mass. You know, the mass doesn't change, only weight changes based upon gravity acceleration, right? And you see the Young modulus for 4,000 and Poisson ratio and other coefficients. Mostly we pay attention more on the Young modulus. So when you need more concrete strength, I think either you copy this property and adjust those properties based upon your concrete strength. So for now, we're going to use default 4,000 psi. And since the first model, we are using line element, which is frame element. And there are default properties, frame properties, but we need to create the wall cross-section properties, right? Just opening concrete rectangular menu, I'll choose the concrete. And this is the wall, 12 by 120. So this is 12 inches by 120 inches, right? So I'm gonna type the section dimension here. So this is the wall section. I'll just keep it. This is all properties. We're not using it. So just I define the cross section for the wall. Proper, but can I have X? I'll duplicate file name. So, all right, 12 by 120 W. Okay, so I'm gonna use this section property for frame element. So what you can do, there are many ways to do this. Since we create the frame section properties, so first thing you can click this, activate the plan view, right? Plan view, but you're looking at the story 10th floor. So for column and beam and wall, you can draw on plan, so that I'll show you here the quick draw. I'm sure everything is in here, but this is a quick icon. I'm gonna click this, right? Quick draw for the column, and I'm gonna choose the section property which I created, 12 by 120. So this is section properties for the column. I'm gonna use it. See that overall shape, and I'm gonna put this one, right? Drop this. So you see that the column is dropped because this is story 10. So I just dropped the column below. So you see that column right there. So on the plan, it showed overall section outline, cross section outline, but on the elevation, if you want, here, this is issue during the recording. I cannot click this. Okay, you see the cross section? So 12 inch wide by 120 inch dip, right? So now there are many ways to do this. Since I draw it, the ETABS is good for tall building design. So easy to we can kind of replicate or copy. So I select the frame member here, right? And you see that in the edit menu, replicate, which is Control R, and I choose tab story. I'm gonna select all these stories, so I'm gonna copy this column all the way down. So this is actual cantilever, but boundary conditions, obviously, since we are using line element, this is supposed to go to assign and join, restrain, right? We're gonna use fix. Everything is restrained. So this is a fixed boundary conditions. So I assign the boundary condition here. All right, let me just save it. Okay, this is homework 1, ETABS exercise, right? yes, since model, while you're creating some model, I always encourage you to continuously, frequently save it, because sometimes software crash. All right, so you see that I can just turn back on if you hold on a second. Yeah, here. Okay, here. Okay, yeah, still. This. Hold on. Okay. Gosh, this is very sensitive. Okay, here. Oh, the extrusion I'll show you. Somehow, this button is not. It's very not sensitive. All right, so we draw the model using frame element. Frame element is line element, right? The second one, so we're gonna try to use the area elements, so that we need to first define the section properties. This case is we are using wall section. This is section properties. Now there is one default wall 1. I'm gonna open it. All right, I'm gonna name it. Okay, W12, 12-inch wall. But default, since we have only one concrete properties, I'm gonna keep it. So this is W12, 12-inch wall with associate with the material concrete strength 4,000. So I change the name. So I have a property similar way here. Activate the plan view, and I'm gonna choose here quick wall, right? Quick draw the wall on the plan. So I click this again. Property I choose because I have only one section, W12. So I'm gonna move and click this, right click. So same thing, since I using the story 10, right? So it show the wall here at the top, the story 10 below. So again, I'm gonna select and replicate again, right? And story 9 to 11, I'm gonna copy. So this case is, it doesn't matter, but let me just select again. I'm gonna assign the boundary condition, go to restraint, fix. I'm gonna assign fix boundary condition here. So this one is also done. Now, second, well, we can try, I'll show you something cool stuff. Since we know that all the floor is identical, so here we have a menu. If you want to draw this wall, which is because of it's identical, right? Activate the plan view. Instead of one story, I can choose all the story, right? So you can guess it, how it works. If I click the draw wall, select the W12, if I draw from here to here, right click, okay, it applied to all the stories, which is very fast, right? I'm gonna click. So now, since I'm moving back to my floor basis, I'm gonna change to one story. So it's easy to create the geometry, okay? Boundary condition, I'm gonna just change to the the fix. Now, as similar to same as the homework 1, I'm gonna just define these meshes, the wall. I'm gonna show you how to mesh it. Go to edit, right here, edit shell. Right here is the divide shell. So default divided quadrilateral triangles into 2x2. So I select all this. I'm gonna divide 2x2, right? So basically here automatically add the one, but I'm gonna choose and go to the boundary condition. I'm gonna make free, right? So basically we have the same condition as homework 1. Now, second, since we finished the geometry and assign the properties, now it's time to create the load. Here, go to define, right? So here we have load patterns. There is default load pattern, dead load with the self weight. Live load is live load. You already, this morning, we had a class, but unit, I'm gonna say unit. I'm gonna choose the others, right? I'm gonna add, not, but I don't wanna at self weight. So unit is 100 kips, right? Lateral load, which I'm gonna use this load cases and say okay. I'm gonna select nodes here and here, right? And then assign the join load for as a forces. I'm gonna choose a unit in global X direction. You see the X direction? I'm gonna assign 100 PSF, 100 kips. Okay, say okay. So I think we are done. Now, one thing I want you to understand is because this is 3D model, right? Which means each node, one node has a 6 degree of freedom. Degree of freedom means something. The displacement on one node has X movement, Y movement, and Z movement, right? And also rotation about X, about Y, about Z. So each node has a 6 degree of freedom. So this structure is just two-dimensional. We don't have much actually out of plane stiffness in Y direction, right? So because this is 3D model, they don't recognize this is two-dimensional, or our interest is two-dimensional analysis on XZ plane. XZ plane, let's say go back to the one, right? So what I'm gonna do is I'm gonna define, go to this analysis. I'm gonna set activity degree of freedom, right? Instead of I'm running 3D, full 3D, I'm gonna run analysis based upon XZ plane. So this is just 2D plane I'm gonna define. So this analysis will run based on XZ plane. So you'll see that we are allowing X movements in X direction, right? UX means X direction movement, and the vertical, which is Z direction, and the rotation about Y direction, right? It's about Y. R means rotation, about Y. So those are 3 degrees of freedom we are allowing for this analysis. All right, so it's time to run the model. So I'm gonna run the model. Let's see, we'll get the same deflection, which is 9.2, 9.24. Let's see. All right, when you run the model, obviously you'll see the ETABS always show the dead load displacement. So here, here, okay, I can move, open here. Let me see. Right, I can, okay, here, displacement, or you could go to display here, deform shape, right? You're gonna choose the unit load, which has 100 kips, say okay, right? And if you hover, 9.313, 9.169, 9.268, right? They are pretty much consistent. I think those, if you wanna run the animation, see that how this structure moves. You'll see that it makes sense. It's moved into only XZ plane, right? See that? Okay, if you want to see it here on the plane base, again, I'm gonna turn off to make sure. Okay, X units. So start animation. See this line in right? So you can rotate it and see, okay, how this move, right? The animation is only working not on the extrusion. So just in case you want to see that what is the cross-section area, cross-section look like, you turn on the both frame object and shell object both, so you see those model has identical cross-section dimension, right? It's 12 by 120 inches. But this case is we are using frame elements, so you need to define entire cross section width and length. But this one, since you're using area element, you only define 12 inches thick, but you draw the wall over 120 inches long, right? So obviously this is the one, example of homework 1. I want you to watch it, right? Follow along entire homework, right? And if you want to record it. I want you to exercise, right? I've done this, I think, basically 1 million times. All right. So if you continue to do it, I think at the end of the this class, you're probably gonna be an expert. So I want you to kind of practice, and yeah, a good amount of time. So all right. Okay, this is end of video. Okay, bye.